Hey everyone, and welcome back to the Deep Dive. Today we are doing something a little different. We're going to be diving deep into the world of semiconductors through this fantastic book, Chip War, by Chris Miller.
A fantastic choice. This book is a must-read for anyone who wants to understand how the world really works.
It's one of those books that just blew my mind. I mean, I knew semiconductors were important, but I had no idea how deeply they were intertwined with history, geopolitics, and even war.
Absolutely. It's a story that spans decades and continents, and it all starts with World War II.
Yeah, it's wild how World War II actually played a role in the birth of the semiconductor industry.
Right. And Miller does a great job of setting the stage by introducing us to Akio Morita.
The co-founder of Sony.
Exactly. But his story begins in war-torn Japan, where he witnessed firsthand the devastating power of American industry.
He called it the Typhoon of Steel. It's incredible how he went from surviving that to leading a company that would later challenge American dominance in technology.
It's a story of resilience and innovation, kind of like the semiconductor industry itself. And the war itself really highlighted how crucial advanced computing power was becoming.
Think about it. Back then, they relied on rooms full of human computers to do complex calculations.
And those early mechanical bomb sites, well, they weren't exactly hitting the mark.
Miller points out that most bombs missed their targets by a mile. Clearly, the demand for faster, more reliable computing was growing rapidly. And that's where our next key player enters the scene, William Shockley.
Now, there's a complex character, brilliant, but a bit of a, shall we say, difficult personality.
He was obsessed with semiconductors. Those materials like silicon that we now know are the foundation of modern electronics. Back in 1945, he even theorized this thing called a solid-state valve to replace those clunky vacuum tubes.
But his initial experiments failed.
The technology just wasn't there yet, right?
Right. The instruments weren't sensitive enough to detect the tiny currents involved. But even though his early attempts didn't pan out, they laid the groundwork for one of the most important inventions of the 20th century.
The transistor.
Of course. And it's at Bell Labs where Shockley, along with John Bardeen and Walter Brattain, successfully developed the first working transistor.
A huge moment in technological history.
Hmm.
But the story doesn't end there. Shockley, as brilliant as he was, also had a bit of an ego.
Oh, yeah, definitely. He was more focused on the fame and fortune that came with the invention than the pure scientific pursuit.
And that ambition led him to establish his own company, Shockley Semiconductor. It's funny how that company actually became a breeding ground for future competitors.
Right, the traitorous eight. These 8 engineers, including Robert Noyce and Gordon Moore, saw Shockley's management style and thought, we can do better. So they left and founded Fairchild Semiconductor.
Talk about a pivotal moment.
Yeah.
It was as if Fairchild planted the seed for what Silicon Valley would become.
Absolutely. It's an amazing example of how talent competition and a little bit of rebellious spirit can spark an entire industry.
Meanwhile, on the other side of the country, you have Jack Kilby at Texas Instruments independently inventing the integrated circuit around the same time.
And of course, that kicked off a whole patent battle with Fairchild, just adding more fuel to the fire of innovation. But what's really fascinating is how the Cold War actually accelerated the development of this technology.
Oh yeah, that launch of Sputnik. I mean, that single event sent shockwaves through the U.S. It was a huge wake-up call.
It was a huge deal, and the U.S. government responded by pouring tons of money into semiconductor research.
They saw it as essential for national security.
Absolutely. What people often forget is that those early days of mass-producing chips were incredibly difficult. Reliability was a major challenge. It wasn't like today where we just take for granted that these tiny components work flawlessly.
And this is where Morris Chang's story comes in, right? The guy who would later found TSMC.
The same one. He arrives at Texas Instruments with a PhD from Stanford, but initially, he struggles.
Really? With that kind of background?
It just goes to show that even the brightest minds had to adapt to the demands of this industry. Chang became laser-focused on improving yields, on making sure those chips were as perfect as they could be. He was relentless.
That's a quality that served him well throughout his career. But while this was all unfolding, the U.S. military was recognizing the strategic importance of these integrated circuits.
Oh, yeah, they were early adopters for sure. Things like guidance systems in the Minuteman II missiles.
Those were a pretty big deal during the Cold War.
Huge. This military demand really drove a lot of the early advancements in both chip manufacturing and design.
It cemented that close relationship between Silicon Valley and the Pentagon that we still see today.
Right.
But let's go back to Fairchild for a moment, because that company was like a talent factory.
A real breeding ground for future leaders in the industry.
People like Gordon Moore, the guy who came up with Moore's Law.
The idea that computing power doubles roughly every 2 years.
Exactly. And of course, Robert Noyce, the co-inventor of the integrated circuit. It's amazing to think how many of these pioneering figures came out of Fairchild.
Fairchild really set the tone for Silicon Valley culture. Innovation, competition, and a desire to, well, make a lot of money. One employee even wrote on an exit survey, quote, "I want to go rich," end quote.
Wow, talk about straight to the point. But while all of this was happening in the U.S., the Soviet Union was trying to keep pace. They were desperately trying to build their own Silicon Valley called Zelenograd.
A fascinating parallel. They knew how important semiconductors were strategically, but their system just wasn't set up for that kind of innovation.
Their centrally planned economy just couldn't match the dynamism of Silicon Valley. And on top of that, they were relying heavily on stealing Western technology.
Right. The book even talks about Boris Malin, a Soviet student who literally smuggled an early integrated circuit back from the U.S. It sounds like something out of a spy movie.
Talk about a risky move. But that copy-it approach, while it might give you a temporary advantage, is ultimately doomed to fail, right?
Exactly. The Soviets were so focused on replicating designs that they often neglected those crucial elements. Mass production, reliability, continuous innovation. They were always playing catch-up.
It's a classic example of how a closed system can't keep pace with the rapid evolution of technology.
Yeah.
You need that open exchange of ideas to really push the boundaries.
Absolutely. And there's this tragic story of Yuri Osokin, a brilliant Soviet engineer who actually invented the integrated circuit independently. But because of the secrecy and bureaucracy of the Soviet system, his work remained largely unknown.
What a loss for the world of technology. It's a stark reminder of how a stifling environment can suppress individual brilliance and hinder progress. You really need that free flow of information and ideas to thrive.
Couldn't agree more. But here's something that might surprise you. At the same time that the Soviets were trying to steal American technology, the U.S. was actually encouraging the transfer of semiconductor technology to Japan.
Wait, what? Why would they do that? It seems so counterintuitive.
Well, remember, this was the height of the Cold War. The U.S. saw Japan as a crucial ally in Asia, a bulwark against the spread of communism. They figured that a strong Japanese economy, fueled in part by a thriving semiconductor industry, would be in America's best interest.
So they were willing to share technology to strengthen an ally, even if it meant potentially creating a future competitor.
Precisely. It was a calculated risk, and in some ways, it did backfire. It helped Japan rise as a semiconductor powerhouse, which, as we'll see later, would eventually challenge American dominance.
It's amazing how these early decisions had such a lasting impact on the industry. Talk about unintended consequences, but that's a story for another time. This is just the beginning of our deep dive into the fascinating world of chip war.
Stay tuned, folks. The story only gets more interesting from here. Now, as we move into the 1980s, the semiconductor landscape starts to shift dramatically. This is where we see the rise of Japan as a major force in the industry.
Yeah, it's like the student surpassing the master in a way.
Mm.
What were the key factors that drove Japan's success?
Well, a couple things came together. First, you had Japanese companies like Sony, who had built a reputation for quality in consumer electronics. They started leveraging their manufacturing expertise to produce high-quality memory chips, things like DRAM.
And they were known for their attention to detail. Remember those transistor girls we talked about earlier? Their dedication to precision really played a role.
Absolutely. It was more than just craftsmanship, though. Japanese companies also had a different kind of corporate culture, one that was very long-term focused. They were willing to reinvest profits, prioritize market share over short-term gains, and they often had government backing to support this approach.
So you had this combination of technical skill, long-term vision, and government support, all propelling the Japanese semiconductor industry forward. How did American companies react to this?
Well, many were caught off guard at first. The speed and scale of Japan's advancements took them by surprise. They started accusing Japanese companies of engaging in unfair trade practices, things like dumping.
Dumping.
Yeah, basically selling chips below cost to grab market share.
Sounds like the start of a trade war.
It definitely created some tension. The book explores different perspectives on this. Some American companies were undoubtedly struggling to keep up with Japan's efficiency and quality. At the same time, there were legitimate concerns about how some Japanese companies were operating.
It raised some big questions about government intervention in strategic industries, a debate that's still relevant today.
For sure. Back then, there was a real struggle between those who saw semiconductors as crucial for national security and those who favored a more hands-off free market approach.
It's a classic tension. And all of this was happening against a backdrop of growing economic anxiety in the U.S. Japan was seen as a rising economic power, and some people were worried that America was losing its edge.
And a prime example of a company that struggled during this period was GCA, a leading American manufacturer of lithography equipment.
Lithography, for those who might not know, is that super precise process of etching those intricate patterns onto silicon wafers. It's like the foundation of chip making, right?
Exactly. And it requires incredibly sophisticated and expensive equipment. GCA, despite being an early innovator, struggled to keep pace with the rapid advancements in lithography technology, especially as Japanese companies like Nikon poured resources into this area.
It seems like they were losing ground technologically.
They were, and they also lacked those close relationships with key customers, particularly the chip manufacturers that their Japanese rivals had carefully cultivated.
So it was a combination of technological stagnation and a failure to adapt to the changing dynamics of the industry.
That's a good way to put it, and their story really highlights how quickly things can change in the semiconductor world. If you're not constantly innovating and adapting, you risk falling behind.
It's a cautionary tale.
Now, over in Japan, there was a growing sense of confidence, even a bit of nationalism brewing within business and political circles. Chip War mentions this provocative book called The Japan That Can Say No by Shintaro Ishihara.
What was that about?
It basically argued that Japan had surpassed the U.S. in some key technological areas, like semiconductors, and that they should be more assertive on the world stage.
So they were feeling pretty good about themselves.
They were. And for American policymakers, it was a bit of a wake-up call. Their strategy of nurturing Japan's semiconductor industry as a way to counter the Soviet threat had, in a sense, backfired.
The law of unintended consequences strikes again. But amidst all this gloom and doom for American chip makers, were there any signs of hope? Any companies that were managing to hold their own or even thrive?
There were. And Chip War introduces us to this unlikely hero, a guy named Jack Simplot.
Simplot.
Yeah, a potato tycoon from Idaho, of all places.
A potato tycoon investing in semiconductors. Now, that's an interesting story.
It is. Simplot had made a fortune supplying potatoes to McDonald's for their French fries. But he saw potential in this struggling memory chip company called Micron, which was founded in, get this, a dentist's basement in Boise, Idaho.
From French fries to microchips. It's amazing how these connections emerge.
Right. Talk about an unexpected investor. Simplot's gamble on Micron paid off. The company, with its scrappy entrepreneurial spirit and Simplot's backing, managed to not only survive, but thrive.
A real underdog story. I love it. It shows that even in a highly competitive industry like semiconductors, there's always room for new players who are willing to take risks and innovate.
And it reminds us that success can come from the most unexpected places. You don't always have to be in Silicon Valley to make a big impact in the tech world.
But what about the big players like Intel? How were they navigating this increasingly challenging landscape?
Intel was a rising star at the time, known for their DRAM chips, but even they were feeling the pressure from Japanese competitors. They made a bold decision to shift their focus away from DRAM and towards microprocessors.
Microprocessors, the brains of personal computers.
Exactly.
This seems like a risky move. DRAM was their core business.
It was a big gamble. But Andy Grove, Intel's CEO at the time, recognized that the PC market was about to explode and that microprocessors would be at the heart of it. He also saw that Intel couldn't win a price war with the Japanese in the DRAM market.
So he decided to disrupt their own business model before someone else did.
Exactly. It was a painful process involving layoffs and a major restructuring, but it was the right call. Intel's bet on microprocessors paid off big time, and they became the dominant force in the PC market.
It's a classic lesson in adaptability and recognizing when to pivot.
It also highlights a key theme that emerges in chip war, the increasing specialization within the industry. Not all chips are created equal.
What do you mean by that?
Well, some chips, like those microprocessors, are designed to be general purpose, able to handle a wide range of tasks, but others are designed for very specific applications, things like graphics processing or wireless communication.
Okay, I see. And this specialization was starting to take off in the 80s.
Right. Chip war introduces us to Qualcomm, a company founded by Irwin Jacobs. They had this vision for using increasingly powerful chips to revolutionize wireless communication.
This is before smartphones and widespread internet access. They were really ahead of their time.
They were. Initially, Qualcomm focused on niche markets like satellite communications for trucking companies, but their expertise in wireless technology would prove invaluable as mobile phones, and eventually, smartphones became ubiquitous.
It's a great example of how focusing on a specific problem and developing a deep expertise in a particular technology can pay off in the long run, even if the initial market seems small.
Absolutely. Now, while all of this was happening in the US and Japan, the Soviet Union was facing its own unique challenges. We talked earlier about how they tried to copy American technology, but their real problem was a fundamental misunderstanding of how innovation works.
They were so focused on stealing blueprints and designs, but they couldn't replicate that vibrant ecosystem that had sprung up in Silicon Valley.
Right. Silicon Valley thrived on the free flow of information, a constant churn of ideas, risk-taking, and a culture that celebrated entrepreneurship. The Soviet system, with its emphasis on central planning and secrecy, was just fundamentally at odds with that.
They were trying to force innovation into a box, and it just wouldn't fit.
And to make matters worse, their focus on technology was primarily through a military lens. They often neglected the importance of consumer markets and commercial applications.
So they were missing out on a huge driver of innovation.
Exactly. Chip War delves into some fascinating espionage stories from this period, like the story of Vladimir Vetrov, a KGB officer who spied for the West.
A real-life spy thriller.
It was. He provided valuable intelligence about Soviet efforts to steal semiconductor technology. It really highlights the high stakes involved in this technological race. Semiconductors weren't just about consumer gadgets. They were seen as crucial for national security and military dominance.
It's a reminder that the line between technological innovation and geopolitics can be very blurry.
Now, speaking of the intersection of technology and warfare, Chip War takes us to the Persian Gulf War, a pivotal moment that showcased just how transformative semiconductors had become on the battlefield.
This was the first major conflict after the Cold War, right?
It was, and it was a decisive victory for the U.S.-led coalition.
And a lot of that had to do with their technological superiority, right?
Exactly. It was a demonstration of the U.S. military's offset strategy, which relied heavily on advanced technologies, many of them powered by semiconductors.
So we're talking about things like precision-guided weapons, sophisticated communication systems, advanced surveillance capabilities.
Exactly. The Gulf War became a showcase for how integrating computing power into military systems could dramatically shift the balance of power. Remember those paveway laser-guided bombs we discussed? They allowed the U.S. to hit targets with incredible accuracy, minimizing civilian casualties and maximizing the effectiveness of their strikes.
It was a game changer in military technology.
It really was, and it underscored just how central these tiny silicon chips had become to global power dynamics. What started in labs and research facilities had become a defining factor in warfare.
It's amazing to think about the ripple effects of technological innovation. They extend far beyond the initial applications. They can impact entire societies, economies, even the balance of power on a global scale.
Absolutely. And as we'll see in the next part of our deep dive, this trend only continues. The post-Cold War era brings new challenges, new competitors, and even more complex geopolitical dynamics, all centered around the world of semiconductors. And now, as we enter the 21st century, the semiconductor landscape shifts yet again. This is where we see the rise of Taiwan as the world's leading chip-making hub.
Taiwan. That's interesting. I know they're a major player now, but
Right.
what led to their dominance?
Well, it's a story that's really intertwined with Morris Chang, the guy we talked about earlier, who was obsessed with perfecting chip yields at Texas Instruments.
Oh, yeah. He later went on to found TSMC, didn't he?
Yeah.
It's amazing how his career almost parallels the evolution of the entire industry.
It really does. He had this incredible understanding of the complexities of chip making, and he saw that the future lay in specialization. Moving away from that traditional model where companies tried to do everything themselves, design and manufacture.
Vertical integration.
Exactly. Chang saw an opportunity to create a company that focused solely on manufacturing the most advanced chips, leaving the design to others.
So TSMC would be like a dedicated chip foundry, essentially building chips for companies that didn't have their own manufacturing capability.
Precisely. It was a bold move at the time because most companies were still trying to do it all. Chang was betting that the industry would shift towards this fabless model where companies focused on design and outsourced the manufacturing.
It turned out to be a brilliant bet. This shift towards specialized manufacturing really unlocked a whole new level of innovation.
It did. It allowed companies to focus on their strengths. So companies like Qualcomm, who we talked about earlier, could pour all their energy into designing cutting-edge chips for wireless communication without having to worry about building and maintaining these huge fabrication facilities.
The fabs, as they call them.
Right. And on the manufacturing side, TSMC was able to really optimize their processes, invest heavily in the latest equipment, and just achieve these economies of scale that made them the most cost-effective chip maker in the world.
It's a great example of how specialization can really create a win-win situation. And it also highlights the increasingly global nature of this industry. Chip design could happen anywhere in the world, but manufacturing was becoming concentrated in a few key locations, with Taiwan, thanks to TSMC, emerging as the epicenter.
And a lot of TSMC's success was tied to the success of their customers, companies like Qualcomm, NVIDIA, and perhaps most notably, Apple.
Apple. I honestly never realized how central they were to this story. I mean, I know they make iPhones and Macs, but I always assumed they just bought chips from someone else. Yeah.
Well, they actually design their own chips. Apple has always been obsessed with controlling both the hardware and the software of their products, and that includes the chips that power those devices. And their investment in chip design, coupled with their close relationship with TSM, has allowed them to create some incredibly powerful and energy-efficient products.
Which is a big reason why they're so popular, I guess.
Yeah.
It just shows the power of these relationships and partnerships in driving innovation. It's not just about individual companies anymore, it's about entire ecosystems.
Absolutely. And while all of this was happening, another critical technology was going through a dramatic transformation: lithography.
Right, lithography. That incredibly precise process of etching those microscopic patterns onto the silicon wafers. It's like the heart of chip making, and it's a technology that demands constant innovation to keep up with the demand for smaller, more powerful chips.
And this is where we see the rise of ASML, a Dutch company that emerged as the global leader in lithography equipment. Their story is really interesting. Unlike some of their Japanese competitors who tried to keep everything in-house, ASML built a global network of suppliers, each specializing in a particular component or technology.
So they were like the conductors of this lithography orchestra, bringing together the best technologies from all over the world.
A great analogy. And that approach allowed them to stay at the cutting edge. Chip War really focuses on their development of EUV lithography.
EUV, what's so special about that?
Well, imagine using light with incredibly short wavelengths, almost like a super precise laser, to etch those tiny patterns onto the silicon. It's a process that requires mind-blowing levels of precision and control. It took decades of research, billions of dollars in investment, and a truly global effort to make EUV lithography a reality.
And ASML was right at the forefront of this.
They were the pioneers, and their success really underscores a crucial concept that Miller explores in Chip War: choke points.
Choke points, what do you mean?
Well, as the industry became more globalized and specialized, certain companies or countries emerged as the dominant suppliers of critical technologies or materials. These became choke points in the supply chain, meaning that whoever controlled one of these choke points had a huge amount of leverage over the entire industry.
So if a company, or a country for that matter, had a monopoly on a technology like EUV lithography, they could pretty much dictate terms to everyone else.
Exactly. And that's essentially what happened with ASML. Even the most advanced chip makers in the world, like TSMC and Samsung, became reliant on their machines to produce those cutting-edge chips. It shows that even in a globalized industry, power can still be concentrated in the hands of a few key players.
It's fascinating, but also a little unsettling how these dynamics play out. It's like this delicate balance between cooperation and competition on a global scale. But we can't talk about the future of the semiconductor industry without addressing the elephant in the room: China.
Right. China has made no secret of its ambition to become a global leader in technology, and semiconductors are at the heart of that ambition. But their journey in this industry has been a long and complicated one.
Yeah, they've been trying to build up a domestic chip industry for decades now.
They have. And Chip War traces this back to the early days of Mao Zedong, when they viewed semiconductors as a symbol of national pride and technological independence. But their early efforts were hampered by political turmoil and isolation. especially during the Cultural Revolution.
It just shows how much politics and social upheaval can impact the development of technology.
Absolutely. And it wasn't until China began opening up to the world in the 1980s that they really made a concerted effort to catch up in semiconductors. They tried to attract foreign investment, license technology, even resorted to, shall we say, less than ethical means to acquire the knowledge and expertise they lacked.
Sounds like they were pulling out all the stops.
They were. But their efforts were often met with resistance, particularly from American companies who were understandably hesitant to share their most sensitive technology with a potential rival. And while China's own domestic chip industry made some progress, it still lagged behind global leaders like TSMC.
The book talks about Richard Chang, a Taiwanese-American engineer who actually tried to build a state-of-the-art chip foundry in Shanghai with the backing of the Chinese government.
Yeah, that was an ambitious project. It was a genuine attempt to transfer knowledge and expertise to China, but it ultimately faced resistance from both sides and fell short of its goals.
It just shows how complex these technology transfers can be. It's not just about sharing blueprints or equipment, it's about bridging cultural and technological gaps.
It really is. And all of these challenges, combined with China's growing frustration with the U.S. and what they perceived as attempts to hold them back, well, that's really what sets the stage for what we're seeing today, the chip war.
A war fought not with traditional weapons, but with tariffs, sanctions, restrictions on the flow of technology, a battle for technological supremacy.
Exactly. Both sides recognize that semiconductors are the key to the future for their economies, for national security, for everything. It's become an existential competition.
And nowhere are the stakes higher than in Taiwan.
The fact that Taiwan, a small island that China claims as its own, is the world's leading producer of advanced chips is a huge geopolitical dilemma. The possibility of China trying to seize control of Taiwan's chip-making industry is a very real concern.
And the impact of that would be felt around the world. It could cripple the global economy and give China a strategic advantage that could reshape the entire balance of power.
Chip war doesn't shy away from these uncomfortable truths. It forces us to confront the reality that semiconductors aren't just about technology and business, they're deeply intertwined with geopolitics and national security.
It's a lot to process. But this book has been such an eye-opener, really highlighting how important it is to understand these dynamics. It's not just about geeks and tech enthusiasts anymore. It's about the future of the world.
Couldn't agree more. So after diving deep into this world of chips and geopolitics, what are your big takeaways? What really stood out to you?
Well, a few things really hit home for me. First, the semiconductor industry is in constant flux. What was cutting edge today might be obsolete tomorrow. Agility and adaptability are key to survival, not just in business, but in geopolitics as well.
That's so true. It's not enough to just have the best technology at any given moment. You have to be able to anticipate those big shifts and adapt quickly.
The other big takeaway for me is just the sheer importance of partnerships and ecosystems. The days of any one company doing it all are over. The most successful players are the ones who can build strong relationships, whether it's with suppliers, customers, or even sometimes competitors.
I think that's a great point. Collaboration is key. And that brings me to my final takeaway. This geopolitical dimension is only going to become more important. Semiconductors are at the heart of so many emerging technologies, from AI to quantum computing, and the competition for dominance in this field is going to have a huge impact on the world.
It's a sobering thought. But chip war really drives home the point that we all need to be paying attention to this to understand what's at stake. It's not something we can just ignore.
Absolutely. The decisions that are made about this technology, about who controls it, about how it's used, will have profound consequences for all of us.
Well said. Chip war has given us a lot to think about, hasn't it?
It has. A real must-read for anyone who wants to understand how the world works and where it's headed.
And on that note, we'll wrap up this deep dive into chip war. If you're intrigued by this world of semiconductors and the forces that shape it, I highly recommend checking out the book by Chris Miller. And if you enjoyed this deep dive, be sure to subscribe and share it with anyone who might be interested. We'll be back with more fascinating deep dives into the world of knowledge and ideas. Thanks for joining us.